Hello and welcome to the Omniscient Technologies webinar, Applying NMT in the Real Business World Scenarios. My name is Dion Wiggins. I'm the CTO of Omniscient Technologies. At the end of this presentation, we'll have a Q&A session, and joining in that Q&A session will be Professor Philip Kuhn and also our CEO, Andrew Ruffner. So during this presentation, we'll be talking about a number of key items. One of them is breaking through the hype, which there's certainly a very large amount of right now. We'll be understanding and comparing NMT with SMT. I'll be introducing our latest product release, which was released several weeks ago, Language Studio Hybrid NMT. We'll be discussing how to decide which technology meets your business case. And we'll look at a couple of case studies. One in particular is the largest commercial MT deployment using NMT technology in the world, which is translating over 100 billion words of content. Okay, so without any further delays, I'm going to go straight into the discussion, but please feel free to ask any questions anytime. The team's on the line and they'll be checking questions and collecting them for the end. I look forward to seeing what the feedback is. So first of all, the good, the bad, and the ugly. So in the industry, there's been a running joke for many, many years that MT will be a solved problem in 5 years. This prediction has pretty much been updated every 5 years since the 1950s. So, you know, it's quite a significant change there. Today, there's more hype about MT than ever before. So we have NMT, and you know, a lot of people are talking about it. Google is probably the one that's hyping it the most, with comments like it's nearly indistinguishable from human translation. Well, the reality is it's still got some way to go. However, there is significant reason to be excited. It has to be kept in context, but many of the languages are getting very, very interesting that were somewhat challenging for NMT before. As an example, one of our Japanese customers showed output from English into Japanese recently, and the Japanese teams actually got very excited about the quality of the content, which had never been seen before from any machine translation at all. Here's an example going the other way. So Japanese patterns into English. Now, I'll give you a moment to read this and have a look at some of the sentences. One of these translations, either black or red, is human. So have a quick scan down and, you know, have a think which one really is human. Give you just a few moments to do that. So if we look at this content, it's a little bit misleading sometimes. So for example, the very first sentence, the coagulation time was determined as described above versus the setting time. Now to me, for a technical document, something like coagulation is probably the best term. If you look at the next one, it also reads very, very well. You carry on down, but about the fourth one down, you'll start to see something a little bit off. So the use of a hearing aid by a healthcare provider is routine versus the use of a stethoscope. So this is one of the first things that you should know about NMT. It has relationships between similar terms. So, okay, hearing aid may be sort of loosely technically correct, but stethoscope is more correct. So I'll let you in on the secret now. The red is human and the black is machine. Now these slides will be available later as well, so there's a fair bit of information on these slides, so we'll make them available for download, and the video will also be available for replay after the call. So just a very quick recap on statistical machine translation, because it's very important to understand the differences. When we build a statistical machine translation engine, we're building up patterns of phrases, and then we map those phrases between a source and a target language. From there, we look at reordering and working out what order those pieces of phrases or entire phrases or just individual words should go into, and that's how SMT works in a nutshell. With NMT, it's quite different. So NMT's task is working along a line, predicting from one side to the other what the next word will be. So the, big, and it needs to predict the word dog in this case. Now the way it does that is it builds a neural network and it builds vectors so that it can calculate that and make its prediction of what comes next. Now, if you want more detail on this, I suggest that you look at one of our previous webinars where Philip Kuhn went through this in a lot of detail. I'm not going to do a technical presentation today. This is more focused on the business side. One of the other benefits of NMT is that it does have semantic representation. So it understands that king and kings have a relationship, uncle and aunt, king and queen, and those kinds of things all put together have a relationship. Now, one of the things that NMT does quite well by design is it breaks things up into what we call subwords. Now, this is done both from a technical limitation perspective, but also so that it can handle different kinds of words, things like inflected forms, unknown words, and also things like compound words. NMT handles very, very well. Okay, so in these examples here, you can see, for example, Obama, and this is broken up into what we call byte pair encoded, where it's taking a main dictionary that it builds of maybe 50,000 to 100,000 words, and everything else is built from little pieces that are byte pair encoded, like you see here on the screen. Now, NMT has a lot of benefits, and SMT has a lot of benefits, and you really need to decide, using most technologies, which one is going to be best for you. I'll also look at what the challenges and issues are in an upcoming slide. So what we're seeing with NMT is that the output is much more fluent than traditional phrase base. NMT does a lot more and a lot better reordering than SMT, especially long distance reordering. So languages like Japanese and German are handled much better. Inflected forms are handled better. Human judgment usually scores NMT better than SMT systems, even when the blue for the NMT may actually score a little bit lower than SMT. One of the interesting things is research focus is really moving away from SMT to some degree and really focusing on NMT. But with that said, both translations have a place and a purpose, both translation technology, I should say. One of the key things is NMT is faster to translate, and I'll talk about speed a little bit later. Then we move on to SMT. SMT does a lot better with less training data. So if you don't have a lot of data, SMT may be a better solution for you. NMT does very poorly when you don't have much data. Dictionaries and glossaries help a lot. SMT performs better on short phrases of 1 or 2 words or 3 words. And SMT adapts much more quickly and easily to domains and writing styles, which can be very important. Okay, so there's a lot of information on here. I'm not going to go through and list off all the details, but just want to highlight some of those key elements. So now we're going to look at the other side of the scale. What are the challenges and limitations? Well, first of all, blue can't be readily used as a reliable score when you're comparing SMT. We typically see NMT scoring lower even when humans rate the NMT output better, as I mentioned earlier. So you can use NMT with blue to compare one version of NMT to the next, but often it's not viable to compare SMT with NMT outright. It requires a lot more expensive hardware, GPU hardware to be specific. NMT systems have been slower to train than SMT, but that's slowly being resolved, and we'll talk about that in a little while. The process is not transparent. If there's something wrong, it's very, very difficult to find out why. With SMT, you can see, I got this answer, this result, because of this data. With NMT, it's very, very hard to find that. The data can't be manipulated easy, so after training, if you've got an issue, the only real solution is fix the data issue and train it again. Okay. NMT doesn't do very well on very short phrases or very long phrases, so that's some of the challenges. Lower quality is a definite issue when you have out-of-domain context. SMT is much more tolerant on out-of-domain context. Word alignment is often less accurate, and we'll talk about that again a little bit later. There's no explicit modeling of coverage or content, so sometimes you get repeat words or content will just simply be dropped, and there's no real way to control that in most cases. Now, with SMT, long-distance reordering is a real challenge. It's very intolerant of unknown words, it's slower, memory-intensive, and CPU-intensive. Phrase translations don't consider context, so if you've got different words with different meanings, then phrase-based can have a challenge understanding that, whereas NMT has a much better control of that. So 5 things that you should know about a pure NMT system. First of all, NMT systems have lower quality out of domain, as I mentioned earlier, to the point that they can completely sacrifice adequacy for the sake of fluency. And we've seen, some sentences you feed into an NMT engine that are out of domain, and you get content that has no relevance at all. You can't understand it. You can't do anything with it whatsoever. It's just random information when it's really out of domain. Whereas SMT at least will be somewhat there. NMT systems have a steeper learning curve with respect to the amount of data, so you need a lot more training data to get a result. Of course, they don't have a monolingual language model in the target language like SMT does, so you have to have larger volumes of bilingual to get that performance up. NMT systems operate on a subword level. They perform better typically with the right amount of data than SMT systems on extremely low frequency words, and that's very helpful. So things like inflected forms or compounds, that's really, really helpful. NMT systems will have lower quality on very long sentences, 60 words or more in length. So again, that's a challenge. Many of these challenges have been addressed in our technology platform, Language Studio, and I'll be talking about those soon. And finally, the attention model for NMT doesn't always fulfill the role of word alignment, and that's why you get some misalignments of words that make things a challenge. But at the end of the day, these could dramatically diverge from reality, and so we've also found a solution for that. So let's look at measurement as an example. Okay, this is an interesting state where we've looked at phrase-based SMT versus NMT trained on the same data, and then looked at sentence length. So when it's relatively short, it's comparable. When it gets really short, I can tell you NMT doesn't do it as well. But as data goes up, NMT does a lot better, but as it gets to the point of 60 or so, SMT actually gives you a better quality translation. So there are ways around some of these challenges, and that's what we'll talk about in the coming slides. So next up, I'm going to introduce Language Studio. This is our new hybrid NMT product, and it's going to address many of the challenges that we've already talked about earlier in this presentation. So Language Studio is an overall hybrid platform. For translation, it integrates rules, statistics, neural, and syntax very, very tightly into a single workflow, single platform. That allows us to take the benefits of each technology and leverage them in a coherent and cohesive manner that ties everything together into a single workflow. We have the capability for a complex language and linguistic processing, things not just as simple as prepare data to translate, but things like sentiment analysis, intelligent conversions, syntax parsing, many other complex processing. We also can integrate with that our machine learning platforms and technologies to integrate other information, other workflows, or access just the machine learning component on its own. Now, Language Studio is integrated with a large number of third-party products, and we have a very comprehensive set of APIs that are available as well. On the other side, when you're customizing your engine, and I'll talk about this in more detail shortly, we have data repositories that can be leveraged, we have data manufacturing capabilities, and we have automated management and training of the entire process. Now, all of this is held together by a very, very sophisticated team that has some serious expertise in this space, that's built thousands of engines, that knows how to get the best out of the right technologies and fit the right technologies to your scenario. So if you look at the 4 different types of translation technologies, we have rules-based, where content is mapped from one language to another via rules between source and target, and that deals with formatting, structure, and reordering control as well. We have syntax, which deals with structural analysis and mapping from source to target. We have statistical, which is taking bilingual patterns of phrases, and that's really good for vocabulary choice. And then a target language model that guides it on word order and vocabulary selection and context. And finally, we have neural, which is based around machine learned models using purely bilingual data. Now, we've made a lot of progress, as has the rest of the industry in many areas, but I think at this point we're leading in many areas in terms of what we've been able to achieve. We've done a number of industry firsts. So if you look at how fast the progress has been, in July last year, to train an engine on the same data now that we are using, it took 4 weeks to train an engine. In January this year, it took 1 week. In May, we moved that forward to 1 day. The exact same data, the time frame is now compressed to just 1 day. On a single GPU, in July last year, we were getting 3,000 words per minute. In January, we were getting 20,000 words per minute. And in May, we're getting 35,000 words per minute on the exact same data. So there's some real progress here. Now, we're able to link all that together with multiple concurrent GPUs for translation to get even higher speed. This is just on a single GPU as a base metric. We've focused on rapid domain adaptation, and this is a first in many areas. We've added support for dictionary, glossary, do not translate, and forced translations. No other NMT platform has that today. So things that you could do easily in SMT, like adding a runtime glossary, are now possible with the NMT only with the Language Studio platform at present. We've focused on getting accurate word alignment, and that enables other functions such as tag handling and format handling to be processed correctly and accurately. This wasn't possible using just pure plain NMT. We had to come up with some new techniques, new approaches. And we have a work in progress. It's not ready to release yet, but word order control. So if you've seen our statistical platform, we have what's called zones and walls, which allow you to control reordering of words or non-reordering of words by blocking them with a wall. Well, we're working on that now for NMT. We don't have a date yet, but it won't be too distant in the future. So as I mentioned, we have things like runtime glossary support, non-translatable phrases, formatting, and embedded tags. One of the things I haven't talked about yet is the hybrid functionality. So this hybrid functionality integrates many features of SMT with NMT to address many of the challenges that are inherent with the NMT platforms as part of their standard offering. NMT and SMT are trained on identical data side by side, and you can switch between pure NMT, pure SMT, or hybrid NMT-SMT at an individual line or sentence level. So in our complex workflow processing, you might find that one technology does one part of your document better. So an example would be a customer we're doing right now with e-commerce, where titles for e-commerce products are often having no grammatical structure at all. So they'll have 3 different ways of saying the same thing in a row. Basically, they're listing search terms. So NMT is not going to do very well with that. SMT, on the other hand, we can control a lot more than NMT. So by applying rules at runtime, we can switch just titles in a document to have SMT with structured rules, and then the description of the product can go back to NMT for a more fluent, longer sentence. All in a single engine. So let's look at customization and domain adaptation next. So the question we're often getting is, how much data do we need? Well, as I mentioned earlier, NMT is hungrier for bilingual data than SMT. Now, this is the same data used in this example, and you can see the number of words. So in the beginning, NMT doesn't perform anywhere near as well, but at about the 100 million mark for 100 million words, 110 million, something like that, you start to get an overlap. Now, this is using Blue Score, so you have to sort of discount the quality a little bit and say, well, NMT may be higher on human judgment, but you can see the same curve. Now, the orange line at the top shows SMT with a very, very large language model, and by large, I'm talking many billions of extra words. Okay, this is not a small language model, but this is something that Language Studio tools achieve with data manufacturing. Okay, so as you can see, there's convergence points. These are sort of typical examples. They will differ between languages and between domains in terms of complexity. But this gives you a good example of how much data you really need. So, you know, if the engine you're building doesn't have at least 100 million words of training data, then you may be better looking at SMT. Now, with that said, we have a large amount of data that you can use from a foundation perspective and also from a industry perspective to build on top of, so that you need a much smaller amount of data. We also do data manufacturing. I'll talk about that shortly. So when it comes to language pairs, we are progressively rolling this technology out over all of our 540 language pairs that we support today. Actually, that number has just been increased in the last few days to 548. And we're building out 13 industry domains that you'll be able to build directly on top of. Okay, so as we build out this data, you can take immediate advantage of it without having to have too much of your own data. So when we build an engine, doesn't matter whether it's statistical or whether it's neural, we start with a language pair foundation. We then add industry data on top of that to build an industry engine. Now, in our platform, we support two types of custom engine. At the moment, SMT is available for both professional and basic, but only professional is available for NMT at this time. We will be making it available probably for a basic NMT at a later stage, but not yet. Okay, so with a basic, what happens is you upload your data, it's processed automatically and trains automatically. There's no human involved, it's 100% automated. With professional, we do a very large amount of work with you, okay? And we do things like vocabulary control, writing style, unknown word management, and all those kinds of things. And we build out a lot of data. So in this next slide, we're going to go through and look at the impact of domains. Okay, so on the very top row, the green color represents NMT and the blue color represents SMT. And what we did was we took public data and we combined it all together from law, medical, IT, the Quran, and subtitles. Okay, and you can see the volumes of data that are there. Okay, so if we took all data together, and you can see the scores were reasonable in many cases, okay, but in nearly all cases, SMT was better than NMT when the context was out of domain. So, for example, medical did very, very poorly when you put it into the law domain. So, just an engine trained on law. Okay, so SMT you can see doing a lot better. But once you started bringing NMT in, you see NMT is often doing much better when you have a lot more data. The key is to have the right amount of data in domain, and that's where we come in with data manufacturing. So with Language Studio, we have a very large data repository, many, many terabytes of data that we've collected over around 10 years. Okay, we also have data manufacturing capabilities that are combined with machine learning and complex linguistic processing that will analyze data and create training data for you. And that makes a real difference. So being able to help you create training data when you don't have enough, or in some cases our customers have no data at all, is a really significant benefit. So building the system out with data is key. In-domain data is key. And only a handful of our customers, even in the 10 years we've been doing this, have had enough data on their own to do a high quality system. Okay, so when it comes to process and workflow, we have very comprehensive sets of processes that are customizable. And with respect to automated management and training, we have a whole set of automated workflows there. That comes into an engine assembly, which is an XML definition of how the engine's assembled, what it's made of, how much weights are applied to different sets of data, and finally that ties together with a custom engine. Okay, so one of the things to understand is NMT is not the only solution. So it's very important to select the best technology for the job. So when it comes to that, you need to look at things like content volume. So is it one large job? Is it one small job, mid-sized job, or many jobs? What's the repetitive frequency? Is it even worth building a custom MT engine? Okay. What is the content domain? Is it something that is suitable for this? Okay. What is the source quality? So we've just had a customer that's taken product catalog from Alibaba in China and had it translated to English, and now they want to translate that into languages like Thai or Indonesian or some of the other Asian languages. The problem they have is they used a native Chinese speaker who knew English to some degree, and the quality of the English is not very good in many cases. Now what happens there, of course, is garbage in, garbage out, so we need to look at ways of fixing the content where we can, and we're doing that with rules and many other ways. We need to look at the content workflow, how it's going to be used. So, if you're doing something like life science, the content is a lot more critical perhaps than something like hotel reviews, where a very low quality review can possibly be discarded even. Often the source on a hotel review is very poor. We need to look at your knowledge of the content. Where is it coming from? How can it be refined? How can it be manipulated? And so on. What is the value of the content? Is it feasible to throw some of the content away, perhaps? So, a bad hotel review that was written very badly in English to start with, maybe it's just not worth translating it. The complexity of that content, so if it's a patent, then it's quite different. The language pair complexity and domain complexity are all relevant. Then what training data is available? What is the urgency? So I mentioned earlier that we have industry engines. So if it's very urgent, maybe you need an engine today or right now, then perhaps using an industry engine and uploading just a runtime glossary might be the best solution. Okay. And what human resources are available. If you're going to customize an engine, while we will do about 95% of the effort, you still need to engage and get involved, and there will be some resource allocation needed. So if you're looking at your project requirements, if you're wanting something like just, it'll be a little bit better than Google, or maybe it's just limited volume and doesn't justify the time and the effort, then perhaps a industry engine off the shelf ready to use right now is your best and cheapest and fastest solution. If you have enough quantity, volume, and you need higher quality, maybe it's more than one project, you might want to consider either a basic engine if it's, not something too big, or a professional engine where you have a little bit more time and you want the highest quality possible. Okay, and you can control that with our project-specific settings if you have more than one project by uploading things like runtime glossaries and various different rules that you can apply in JavaScript. For high volume, high quality single project, then maybe you're looking at something like a custom professional engine where you pick the data, we build rules, and we build a very high quality result. So there's a whole range of choices here. These are just a subset of them. And when you create an engine with us, our project manager will go through what the checklist is and guide you to the best path to build your engine. Okay, so let's look at some real-world case studies. And let's go through these case studies in a little bit of detail. So the first case study today is complex user-generated travel content. Okay, now with user-generated travel, we have many quality challenges. It could be a non-English speaker who's learning English and writing very poorly. It could be just somebody lazy who doesn't put any punctuation, and you've got 5 paragraphs with no capitals, no commas, no periods, no brackets, no punctuation whatsoever. Or it could be very high quality, or a mixture of both. So there are ways to detect and manage that. There's in this case, high volumes. We're talking millions of reviews a day. Multiple language pairs, so we're going to a large range of language pairs here. It's the same English content being processed, but it's going into a variety of languages. And then there's a very complex workflow that's doing real-time measurement, routing, and processing of content. It's determining the best technology through real-time linguistic analysis and pre-processing, and it's a repetitive cycle for learning and processing and reprocessing data. So let's look at that in a diagram now. So what happens is the content comes in, it gets pre-processed, so common spelling errors are addressed, common punctuation, grammar, all those kinds of things are addressed, normalization of content is applied, and then we do analysis of the sentence in real time. And we can determine, should we use SMT, should we use NMT, should we use a hybrid approach that integrates NMT and SMT together? We have those choices available. We then send that to translation. We then look at the final quality score. If, in this case, if the score is above 60, it goes live instantly. No human anywhere in the process. If it's between 40 to 59, it goes for a light post-editing and then goes live. And in this case, the company is using what we call monolingual translators, where the light post-editing is by a target language speaker only, and it's just making it more fluent to look like it is near human quality. Okay. Any of that feedback from post-editing then goes back into the engine for retraining. If it's between 30 to 39, we store it for later retranslation, and we calculate how many times it's been sent for retranslation. So each time the engine is improved, we send it again for another cycle. And we can be improving our engines maybe once a week for a customer like this. But if it's very low, it's probably just the source is bad, we just discard the whole translation. In this type of content with travel reviews, hotel reviews, you've got enough volume that you can say, well, a certain percentage I can throw away, it's not worth fixing. Okay, so that's an unusual scenario, but it's real world as well. It does happen. Now, our next case study is the largest commercial NMT deployment to date. Okay, we've had a very long-standing business relationship with LexisNexis Univencio. They were our very first customer with our SMT platform around 2007. They have built over time 3 or 4 or more very strong employees that understand our technology, understand their data, and work with it very closely to build a complex system. Now, patents are very, very complex. So they've built this expertise out, and that means much smoother running. They've been able to build their own rules, their own workflows, and even build their own engines and train them themselves. When we set out on this project, we sat down and we defined the roles where the LexisNexis team would focus on the translation-related tasks, the pre-processing scripts, ideas for improvement, and pre- and post-processing all around that, where we would focus on optimization of the core translation tasks and training engines while developing the core training pipeline. So when we were working with LexisNexis, this was pre-release, and we were learning a lot from Lexis. Lexis was learning a lot from us. We worked out how to build a very, very scalable and powerful platform using hybrid NMT and SMT. So the base requirement in this project was to translate 100 billion words of English patent documents into Japanese. Now, Lexis had a lot of legacy code that they were able to leverage from building patent engines in other languages and other language pairs. That meant that they could reuse it. Our workflows are the same. So it was backwards compatible all the way. That meant they could hook straight in. All the core concepts were established, and we could just start straight away. Also, our Language Studio APIs are backwards compatible. That integrated with their external systems, and it was a matter of simply plugging it in, and it worked. That makes a big difference to the effort required on their part. Now, patents are complex, and NMT alone was not sufficient to meet the technical needs of the project. There was a lot of shortcomings in traditional NMT, and we had to overcome those. So collaboratively, we worked with the functional requirements with the Lexis team, and we looked at what were the limitations, where we were getting hiccups, and where was it going fast, where was it going slow, and what were the challenges. And we were able to overcome many of those issues. We're still working on a few issues, and we'll improve that. And as we get their feedback and as we try things, we will certainly be able to run content again that's already been processed and get it out the door again at a higher level. This is a living, moving technology right now. There is so much research going into this, and it really is changing rapidly. The Lexis team was able to perform a lot of tests ranging from evaluating technical experiments to performance optimizations, and their feedback was absolutely crucial to this project's success. Now, if we look at the core tasks were to take millions of bilingual patent documents, and not the entire document, just pieces of it, extract data that was bilingual between an English document and a Japanese document, and then align every sentence. So we had to match the sentences and align them, and we ended up with I think somewhere in the vicinity of about 20 million sentences. Okay. Then we had to train the engines, and we did many, many training runs, trying different techniques, different approaches, refining things like word alignment and many other things. We did a lot of work analyzing the results, looking at possible issues, solutions, and working on probably some of the most complex texts in the world to try and get really high quality results. Okay. So when we look at the Language Studio platform, just a quick peek at our core architecture from a high level, you can see that there's a lot of pieces. But if I just zoom in quickly onto scale, so we're architected to scale from the outset. We tested on 5,000 parallel GPUs. We made sure the system was robust and could scale up to that level. Now, if you recall earlier, I was talking about translating at 35,000 words a minute per GPU, so you can imagine the types of volumes that this can scale with. Now, we use a series of load balancers and a series of management layers in front of that, such as the translation workflow for pre and post processing. And we look at utility servers that also scale for things like word segmentation, sentence segmentation, tokenizing data, and many other NLP processes, so that they scale very, very seamlessly as well. So the entire system is designed to scale from the outset, and this fit Lexis's requirements very, very well, because they need to process, as I mentioned, 100 billion words of content. So looking forward, as more data comes in, we're obviously going to be improving the engine. Now, the nature of patents is that patents are released to the public every week on a regular basis. So we will have an ongoing stream of new patent data that we will periodically need to update the engine. We'll be working on rules and other data, and we'll work to refine those rules and refine the data and improve many features within the platform and the data itself. There's still experimentation going on how to handle things better, things like formulas and many other things like that, how to detect them better, how to lock them in so they don't get touched and translated. Right? All those things are very, very complex. And pending the success of this project, it's expected that we will go on to some other languages, which could take us well above another 500 billion words of translation in total. So, you're talking about some very, very, very serious scale and volumes here. So I'm just going to recap now before we go to questions. So if you have any questions, I can see there's 3 or 4 questions there already, but if you have any questions, please don't hesitate to ask now. Drop them in the question window, and we'll, Andrew and Philip and myself will be able to answer them shortly. So I just want to recap. So as you can see, I think Language Studio is the most sophisticated commercial NMT solution on the market today in terms of scale, control, workflow, and customization. NMT is a huge step forward, but it's not where the hype would lead you to believe it. So please understand, go through presentations like this one and understand really what the challenges are, what the benefits and what the limitations are, and apply the right technology. It might be a combination of NMT or NMT only, SMT or other technologies tied together to deliver what you need as an end goal. Okay, so with that, I'm going to pass over to Andrew, who's going to manage the questions. Just one very last point I'd like to raise before the Q&A. We'll be at Loqueld in Barcelona in a few weeks' time, between May 14 to 16. If you're interested to learn more, please do come and see us there if you're there. Otherwise, we're happy to set up an appointment to meet either online or at the event. We can do live demos for you and walk you through the technology. Okay, so I hand it over to you.
Thanks, Dion. So yes, we've got a number of questions. So maybe we start with one that is not in the question window but came as a direct question, which is probably good before we go into some more technical. But there was a question as to whether you could explain the process of data manufacturing.
Okay, sure. So data manufacturing isn't simple, and we do different data manufacturing depending on the requirements of the project. So our project manager will, the very first thing we do when we start a project is to sit down with you on a meeting, and we work out what are the requirements, what data do you have available, and then we look at where we can get data from. In many cases, we have a lot of suitable data, let's say industry data in our repository that we can apply directly. In some cases, we don't have the exact data you want, and that's where we have a lot of AI tools that look at our repository and try and extract content that is of a similar nature. We do things like terminology manufacturing, terminology analysis, terminology resolution, and we get you engaged with that. But a key part of the data manufacturing for NMT is to create high quality bilingual data, and that's a key process that is built in behind the scenes through an automated workflow. The simplest way to describe it is we analyze your content and we try and create bilingual content that's very similar.
Okay, thanks, Dion. The next question is whether you or Philip, I guess, could elaborate on why blue isn't ideal for NMT. I guess that's what we're saying, but blue has got its advantages and disadvantages, so maybe the two of you could comment on that question.
Sure, Philip, you want to have a first go?
Yeah, sure. There's always various trade-offs in evaluating machine translation quality. So one key thing is the distinction between adequacy and fluency, how close it is to the source and how fluent it is in the target. And there are often different trade-offs. Neural machine translation is generally more fluent, but makes more errors than adequacy. So some of these things are captured by blue in one way or the other. So this is just an observation where we track continuously how humans rank performance and how the blue score ranks performance, and we just noticed that the neural systems are not properly placed there on that kind of line from human to automatic judgment.
Okay. Dion, do you want to add to that, or?
Sure. I mean, some of the things we've seen and I think other researchers have shown the same, is often NMT can score in the blue scale slightly lower than SMT, but on a human evaluation, it's determined that the NMT version was actually better. So, I think, NMT is really, using the blue metric with NMT is fine as long as you're measuring things like historical improvements. Is the quality of my engine going up? That's no problem to use blue. But if you're comparing, against an SMT system and an NMT system, sometimes the results could be a little bit misleading. And I think the best way is still to have some level of human correlation.
Yeah, and maybe I should add that we observed that several times in the past when we had different types of technology, that the blue score is certainly not always the right way to compare different types of technology. For instance, rule-based systems get really, really low blue scores, even if they are comparably good.
Right. Okay. Andrew.
One other question here was related to the volume and the domain specifically of training data. So you obviously talked about the fact that we need significantly more training data for neural to get to the inflection point where it actually becomes better. So the question here relates to how strictly do we need to focus that data to a particular domain? So do we really need in-domain data at very high volumes, or can it also be somewhat broader?
Let me have a first go at that. So NMT doesn't do well on out-of-domain content. So there's two ways to resolve that. One is to manufacture data. The other is possibly not to use NMT at all, or use a hybrid where it's looking at the quality of the potential output and determining which is the best technology in real time. But in languages where either there's not a lot of data to train on full stop, or there's not a lot of in-domain data, even if there is other data, perhaps SMT is actually a better solution than NMT. So what I really want to stress is that NMT is not the be-all and end-all of machine translation. Sometimes, as you've seen in some of the charts we put in this presentation, SMT is actually giving a higher quality.
Yeah, I should also add that, there has been already a lot of work in domain adaptation for SMT, so we have fairly reliable techniques there. So it's a bit the early days for neural machine translation. So if you just train on in-domain data, we definitely observe the effect that the performance drops off really, really quickly once you leave that narrow domain. But there are various strategies you can remedy that, and we are currently exploring that. So maybe one idea is, for instance, to train on as much data, general data as possible, and then just fine tune on the in-domain data. That gives you some of the robustness back.
Okay, so one of the sort of related questions that was asked, somewhat got to do with training data here as well, is whether you actually recommend to use NMT for patents in general, even if there's not a lot of training data available. That's, I guess, a somewhat related question, so maybe you can comment on that.
Sure. So with patents, fortunately, we have a lot of training data. And one of the things I mentioned earlier was industry engines. So we have a patent and legal industry engine in many languages available to start using. And then you can add whatever data you have on top of that to strengthen it in your particular domain. But patent and legal, we have a very, very solid base foundation industry level and set.
Okay, so there's another comment or question that just came in, basically saying that what you're basically saying with NMT, that this is really only for large agencies and not for small ones.
No, I wouldn't say that at all. The key with the Language Studio platform is we have a very large amount of data for you to build on top of already, meaning that you're on the same footing as a large agency when it comes to this. So through our data manufacturing capabilities and through the repository, the industry engines, and all those kinds of things, we allow a lot of the barriers to fall away that mean that the smallest of companies or the largest of companies are, for the most part, on a reasonably level footing. Of course, if you're somebody who's got millions of segments in one domain, then you're a handful of those companies that are in the world, and yes, we can probably do a better quality fine-tuned engine to your very, very specific domain. But with that said, you'll still get a very high quality engine that can be built from data manufacturing and from your existing TMs. Even if you've only got 10,000 TMs, or in some cases we have customers that come to us with no TM. So, it's not unusual for a language service provider, for example, for a customer to come to them and say, hey, I want to build I want to do this translation. It's a big job, but I don't have any legacy data. This is the first time I'm localizing. Well, we've got a solution for that as well, and that's data manufacturing.
Thanks, Dion. So one of the questions also, and I think that sort of relates a little bit to the whole discussion around training data and what you were talking about right now as well, is what's your experience with smaller projects? So if you've got 10,000 words or less, how does that work with SMT, NMT? How do you effectively deal with that?
The easiest way in this case is using our industry engines, or alternatively a basic engine. So industry is off the shelf, take it and use it, add a little bit of runtime glossary perhaps. If you want to fine tune it a little bit more towards your domain, you can take that industry and you can add your data to it, and in a matter of hours have an adapted engine. Now that's very, very low cost, and it's very fast. So even with 10,000 segments, it's probably worthwhile to at least adapt an industry engine very quickly to meet your specific requirements somewhat.
One of the questions that's a little less to do with NMT is, how do you deal with, or can you were talking about the complex linguistic processes that we support in Language Studio as well. Can you maybe elaborate on those a little bit?
Sure. So when it comes to processing and translating, we have 26 steps in the translation standard workflow. And in that set of steps, every second step allows you to inject your own JavaScript rules. So some of those rules can be very, very complex and some can be simple. So it might be in one of the early JavaScripts just saying, right, block out this big piece of content here. I don't want you to translate that. I only want you to translate these parts. So it could be, for example, an XML file where you only want to translate 3 fields out of 100 fields. Okay. Later on, there might be more complex lookups, like in the travel domain, where it's going out in real time and it's it's looking for a currency that's not in euro, and it's going and getting a real-time exchange rate and actually doing a conversion to euro in real time. There's lots and lots of things we can do, but there's also some less complex processing that's worth mentioning too. Things like runtime glossaries, which support both just absolute rules and regular expressions, do not translates, and pre-translation corrections to fix known problems in the source. Like there might be consistent misspellings or some very basic errors that can be addressed. And finally, post-translation adjustments for the little things that annoy editors, like you might want to have a style guide that has 3 spaces after a colon or a non-breaking space between numbers and units. You have full control of that.
Okay. There's 2 questions which are not related, but I'll just throw them out and then I'll allow you to answer them both. I know one of them is going to be short. So one question was all related to integration. The question was related to CAD tools, but I guess that's sort of the broader integration question, so maybe you can spend a minute or so to quickly comment on that. And then there's another question that is a little bit more complex to answer, and that Philip probably might want to jump in on as well, and I'll just read it. With monolingual light PE, how do you manage the risk of delivering a translation that is linguistically fluent yet does not convey the meaning of the source? Moreover, how do you handle the risk of feeding such translations back to the MT as valid training data?
I guess that one's probably more for me. It's more of a workflow issue and content issue. So, I mean, when we're sitting down and having our early project meetings to understand what you're trying to do, we can give you some recommendations there. Would you use something like monolingual translation on life sciences where, you get it wrong, somebody dies? Absolutely not. But if you've got hotel content, let's say it's a hotel review, and you get, in English it says the bed was dusty, and in French it comes out as the bed was dirty. Okay, it's not a perfect translation, but the message is conveyed, it reads well, and you haven't lost the real meaning. And so there's situations where monolingual translation fits, and there's situations where it doesn't. And that's the key difference here. In terms of, feeding such translations back into MT, again, this is a less sensitive domain. So obviously the engine's only as good as the data that you're feeding it, but dusty versus dirty, I don't think is too big an issue. And statistically, the word dusty is probably going to be the right word next time around anyway. This is a lower statistical probability, just feeding one slightly off translation in.
What about the integration? Would you comment on that quickly?
Integration-wise, pretty much all the key TMS platforms ranging from MemoQ, Deja Vu, etc. We have a list on the website, but we also have some new connectors in the works that are coming out shortly that will expand that coverage even further. I guess the last thing there is also our APIs. Today we have a .NET and a Java API. We also have a very comprehensive REST API that will be released in the very near future.
Okay, thanks, Dion. And I guess then there were 2 questions still that related to some of the domain relevance and the metrics that you talked about in your slides. So the question there was, can you elaborate on the language pairs that your examples were based on, and then what of the language pairs that you use, if any, in relation to the domain relevance?
Yeah, so I did that experiment with the domain relevance. So this is something we observed broadly. The actual numbers that we reported there on in domain, out of domain, on legal law, also on German English.
I'm just wondering, Philip, would you mind, we could sit out a couple of minutes to maybe elaborate a little bit on some of the very specific things that you did and the findings. I mean, I know Dion went over it, but it was very short. So.
Yeah, so this is born out of our experience when we train systems with a small amount of data, that the translation quality was really bad for neo machine translation, and this has been observed by several other research groups and industry groups as well. So we try to track down why that is. So our first suspicion was that out-of-domain effect. So that's what we explored by just training different engines on specific data sets that are all from very, very distinct different domains. So the law data was legislation of the European Union. That's a publicly available corpus. You can train a system on that. There's also medical corpus, IT corpus, things like that. So if you just train an engine on one domain like this and then try it on something else, you always see degraded performance. But with neural NMT, you get degraded performance to the point that you have an output that is completely unrelated to the input. We did the same thing then to figure out maybe it's just the amount of training data that is compounding the effect, or maybe that's the root cause. So that was the other experiment where we just trained systems on different amounts of data. We always halved the amount of training data up to the point of about 1 million words of training data. And then we saw the same effect, that the neural systems are able to learn the fluency of the language and produce output that reads very fluent, but is very, very unrelated to the input. So it does need about 10 million words of parallel data to get to the level of statistical MT. That we observed on several language pairs. So the numbers we saw there were, that we presented here, were on Spanish English.
Thank you, Philip. That helps. So we got 4 minutes to spare. Before I hand back to Dion, I just want to remind everybody that this webinar has been recorded. We will make this webinar available online within the next 48 hours on our website. So if you've missed the first part, or you would like to re-listen to it or pass it on to somebody else, this webinar will be available online within the next 48 hours. Thank you very much. Dion, back to you.
Okay, so just a reminder as well, we have a booth at Localization World, or if you'd like a demo online using one of the online meetings, we'd be happy to set that up to you, or we'd be happy to see you at Localization World and give you a live demo there. Okay, thank you very much for attending today, and we hope to see you again sometime in the future for our other webinars. Have a great day. Bye-bye.